We've now added tuples, we've added lists, we started to see the kinds of things we can do with them, all the sorts of things we like to do. We can slice, we can index, we can mutate the list, we can apply functions to all of those pieces. We're going to add in one last data structure that is a further generalization of the kinds of things we've been building. And that data structure is a dictionary. So a dictionary is a generalization of a list, but now the indices, the ways to get to elements of the dictionary, don't have to be integers. And if you think about it, a list is a linear sequence of things, and it's indexed starting at 0, 1, 2, 3, all the way up to the end. Now with dictionaries, the places or the ways to get to elements of the dictionary can be any value that's immutable. What does that mean? First of all, we're going to start referring to these indices not as indices because that implies integers, but as keys, because the keys can be arbitrary in form. And a dictionary then is simply a collection of key value pairs. That is a pairing of some key and an associated value. The syntax for this is shown here. We use curly braces to indicate that this is a dictionary. And each of the pairings is a combination of some key, a colon, and some value. They're separated by commas. So the commas tell me where the ends of each one of those are. And so I'm giving the name month numbers to a collection of Jan 1, Feb 2, Mar 3, and 1 Jan, 2 Feb, and 3 Mar. So I've got pairings both ways. Each pairing has both a key and a value in it. Okay, if I've got that, and in fact I'm just going to show you over here, I've got month numbers defined, and it is that pairing of these pieces. Now, what I can do is I can start doing things on this. So the first one is if that's month numbers, one of the first things I can do is I can get out elements of it. So I could say, for example, if I want to get the value associated with a key, I simply give it that name, or that value of the key rather, as an index. And it gives me back the thing I'd like. Or I can say if I want month numbers of the value associated with the key 2, I can get back that as well. So we get things by giving it a key. This looks a lot like list, except that now the things that go in are arbitrary expressions. They don't have to be integers. It's also important to notice, there's what we can do if we give it a second one, it's important to notice that the entries in a dictionary are unordered, and they can only be accessed by a key, not an index. And in fact, if you look back on my idle screen, you can see when I printed out month numbers, it gave me the dictionary, and notice they weren't in the form that I typed them in. I typed them in with Jan of 1, and yet it has 1 and Jan as being the first element of it. And so if I somehow say, gee, I'd like to get what I think is the 0th entry of month numbers, which would be that 1 Jan pairing, it's going to complain. Because in fact, I can't index by number, I have to index by key. Okay. So what can we do with dictionaries? Well, we can do insertion. So for example, I can go over to month numbers and I can add something new, and I would do that as you might expect. I'm going to give it as an assignment statement saying, associated with the key APR as a string, I want the value 4. And that has now added to the dictionary month number so that if I ask for the value associated with the key APR, it gives me back 4. So I've just inserted something into there. I can also iterate over a dictionary, and I want to show you an example of this. I'm going to bring this up here. I'm actually going to type it in over here. I'm going to create a variable called collect, which is going to be initially an empty list. And then I am going to loop over this dictionary I created, month numbers. So I'm creating an iterator. E is going to vary over each of the elements of that. And I'm just going to append to the end of collect that entry. And if I now look at what collect is,